morning, everyone, and welcome to the Sons of Sequoia podcast, broadcasting live from Wheat Ridge, Colorado, the home of the champions. Today is Friday, August 20th, and we will be discussing a film, because it's Films on Friday, a documentary from 2008 directed by Ian Chaney entitled The Most Unknown. I really enjoyed this. How are you this morning, Michael?
I'm doing fine, David, and I enjoyed the movie too. It's very, very interesting. When it began, I wasn't really sure where it was going, but I really got into it, and it's fascinating. So many takeaways from this film.
100%. So I think we can begin our discussion by sort of discussing the setup of the film. So the film is called The Most Unknown. It's a documentary film made in 2018 by director Ian Chaney. And here is what happens. And I'll pull up the IMDb just so that we can have a bit of a context. There are 9 scientists that this movie follows. And here we go. And it starts with Jennifer McAlady. And she's in a cave and she's researching some primordial fungus or whatever in this cave. And what we have is she travels to Italy to meet David D'Angelo, who's a physicist who's trying to discover dark matter. So David sort of educates Jennifer, who's a PhD on microbiology, about physics. And Jennifer shares with David insights about his physical experiments from her perspective as a microbiologist. And then David travels north, I am assuming, to meet with Axel Clermans, a cognitive psychologist. And then he travels to the Western America to meet with Luke McKay, an astrobiologist. And then he travels to Hawaii to meet with Rachel Smith, an astrophysicist. And so what you get is these cross-disciplinary scientists going and looking into each other's works and discussing and sharing. And it's a globe-trotting, cross-disciplinary adventure that introduces you to 9, 10 extremely bright and talented people who are doing science in the trenches, doing real experiments. And a lot of the science, one thing that unites the science that they're doing, is that they're looking into things that we don't know. And they're trying to discover something about the world that we previously had not known. And that's what the movie's about. Would you say that's an accurate description?
That's very accurate. And I think that the thrust of this movie is the personalities of the scientists that are there talking to each other. And they're very, very bright in their field. And they're talking to someone in another field. And so when you have 2 bright people in their own field talking, it was fascinating how the conversation played out. And in the conversation, they would explain to each other what they were doing, but they also respected each other in that, I'm a physicist, you're a microbiologist, you don't understand physics, so let me explain it to you where you can understand it. And they would understand that. Mm-hmm. And it wasn't like, they respected what each other knew, and also the limits of what they knew. And also the other thing that struck me is that they all were intelligent in their field and knowledgeable, and they were all doing work in their field. But one thing I began to notice is that the work they were doing was different kind of work. Mm-hmm. One was, like you mentioned, like empirical research. The other was looking at different types of hypotheses. The other was looking at trying to understand experimentation. And so all different kinds of approaches that they had. There's a lot of takeaways of this movie. 1 is just the personalities. 2 is all the different fields. And 3 was a scientific approach and the scientific mind thinking about things, even things they don't understand. In other words, when a physicist was talking to a psychologist, a clinical cognitive psychologist, then they respected what they didn't understand, but how they approached that was more of a scientific approach. Mm-hmm. And they tried to understand what was being said. And I thought it was fascinating. So many takeaways from this movie.
Yes. And one thing that was a takeaway, and I mentioned this to you earlier before the show started, that we didn't even discuss yesterday because I took a peek, and I try not to take a peek at movie reviews before we review a movie.
Hmm.
But a lot of what the critics praised about this movie is that it took all these scientists and it humanized them. And it says, for a group that's often vilified or demonized or misunderstood, what you see is that these are people that are trying to answer questions about the universe, and they're smart people, but they're not intimidating. They're approachable. They're congenial, and they're hardworking, and they're doing the work to try to get to these conclusions. These might be some of the smartest people you'll ever meet, but there's so much they don't know. And I think one of the reasons we may have not picked up on that is because it's like, yeah, that's obvious. Yeah, scientists are real people. Yeah, scientists work hard. Yeah, scientists don't know a lot about the universe. But they're working to try to understand the universe more. But I think that a lot of people in this world where, science and knowledge is vilified, they say, oh, the scientists just want this and that. And they think there's some sort of ulterior motive. But when you talk to real scientists doing real work, there is no ulterior motive. They want to discover these things so that we know them, so that we know something we didn't know previously. And there's no agenda. It's not. So, I mean, that is one good thing about the movie. It shows you that there's a lot of scientists all over the world working on different things and working hard. And they're just normal people. They're not agenda driven. They're not funded by some sort of shadowy cabal trying to get at some conclusion. They're really trying to figure out fundamentally what's going on in the world.
And when you begin talking to these scientists, one thing is that you'll notice is that, like you say, they're just normal people, and they have no agenda. Actually, they do have an agenda. Their agenda is to learn as much about this as we can, and it's not attacking anybody or blaming anyone or talking down someone else. And because of that, they are super engaging, super nice, super friendly. They'll talk to anyone and tell them about what they want to do, and what they're doing, or what they're learning, or what did you learn? I want to learn what you're doing. Oh, well, tell me. And so it's not that they are much more engaging than someone who has an agenda out there saying to try to vilify someone who they don't understand.
Yeah.
Scientists don't do that. They engage people, and they want to learn more from their colleagues and also the people in the different areas, because they love learning and they just want to learn from other people.
Mm-hmm. And I think that one of the reasons we didn't catch on this is because you've worked in research. And I've held jobs that were science adjacent. I never worked in research. But I remember a conference where it was on climate change that I was at. And there was a Nobel Prize speaker just discussing how climate change was unequivocal. Like, it's obviously happening, and there shouldn't really even be a debate about whether or not the causes are man-made, because it's clear from the data, and she's presenting all this data, that it is. And it's clear that, yes, there are other things that contribute to climate change, but we can't control those things. We can't control our greenhouse gas emissions. So, like, if you say, only 80% of climate change is due to human activity, the other 20% is just natural, or even if it's 50-50, even if it's 90-10, we can't focus on the 90 that's out of our control. We have to focus on the 10% that's in our control. And that was like her remark. And I remember I was sitting at this conference with, I don't remember the guy's name, but he was one of the chief educators in earth sciences at the Denver Museum of Nature and Science. And he was saying, yeah, I mean, I can't imagine the grief this lady gets, because I'm trying to educate children about climate change, and I'm getting parents. They're coming at me, and they're saying, don't spread these lies to my kids. Like, don't tell my kids something that's happening that's not. Climate change is obviously fake. It's obviously an agenda by these people that want to do this and that and that. And he's saying, I'm a scientist. I don't have an agenda. And it's tough to be called out on stuff like this. So I can't imagine this lady who's doing this research. She was on the Intergovernmental Panel on Climate Change. I believe her name was Susan Erickson. But he's like, I get called out as the guy that runs the Denver Museum of Nature and Science. I can't imagine how often she gets called out on doing the work that she does. And it's kind of sad because what you see in this movie is these people, they're not agenda driven. They're data driven. And they're just sort of trying to describe the world as it is, and they're trying to test hypotheses, but they're not trying to test hypotheses for someone's purpose. They're trying to test hypotheses to get at some sort of knowledge of the world that we didn't have before. So
I think the distinguishing factor, you mentioned it, you touched on it, is that a lot of times the general public come up with a conclusion and they ignore the data. The scientist looks at the data and let the data support a conclusion or support a hypothesis.
mm-hmm.
Two very different approaches. And one, it says, I don't care what the data say. This is what I believe, regardless of what you can show me, which is true or not true, or that you can measure or not measure. But a scientist does it the other way.
Yes, and I think before we get back to the movie, that was one issue that we had with this last year in public health. Epidemiologists and public health officials, they're testing hypotheses. And some of the suggestions they make may be not as effective as they thought they were going to be. But really, what you learn from these scientists in this movie, and what we saw last year, is that our public health officials, they do this work and they work hard and they're trying to provide solutions or suggestions that may be helpful, but they don't know everything. The fascinating thing is these people at the top of their fields doing this research, they're sort of united in the fact that there's so much they don't know. And like you said, the public perception of scientists is they know, they have an answer. They're going to give us an answer. And really, they don't know, but based upon what they've learned, they have a suggestion. And that suggestion has a greater likelihood of success than just sort of throwing a dart at the wall. Do you see what I'm saying in terms of...
Absolutely. And the public, like you will bring forward a hypothesis and say, this is very likely. And from the data, it shows that this is 80, 90% likely. So that's very statistically significant. But the public will say, okay, so there's a 20% chance that it's not likely, or a 10% chance that it's not likely. That's true. Yeah. That's what this data show. So therefore, it's not true.
Mm-hmm.
They'll focus on the 10% and not the 90%.
Yeah.
And say, well, the data show that it's not effective. No, the data show that 10% is not effective. So therefore, it's not effective.
Mm-hmm.
So it's just backwards. And so these people understand that. And so when they start approaching each other in different fields, they understand that, they respect that. So they have the common mindset when they talk about another expert in another field. And they say, oh, well, tell me what you know. And they begin explaining it. And so we saw that in this movie, which is fascinating.
Yes. So, we've been soapboxing for about 15 minutes. Should we get a little bit into what the movie was about? Because we haven't really discussed the movie that much, have we?
Not yet. Well, like you mentioned, I was a scientist. I used to be a scientist, and I worked for 5 years in a research lab, and talking with some really, really super smart people. I was lucky, and to be around those really smart people. And we did a lot of good work back then, and we did a lot of different things, and they brought a lot of projects to our lab. But one thing that when I got there and I started working, I began to realize everybody is so nice and everybody is so helpful, and everybody is oh, you don't understand that? Here, let me help you, and help you do things, help you understand things. There was no real conflict from where I saw. The only conflict there was when people felt bad that they didn't have enough time to learn more of what they're doing.
Mm-hmm.
They wish they could spend more time on it because we'd move from project to project.
Well,
go ahead.
I do think, there's probably the fascinating thing with this is I'm sure it's a little bit cutthroat because, and I'll bring up an example from the movie. Rachel Smith, she's an astrophysicist, and she was studying the gas composition around forming stars. She seemed extraordinarily nice, affable. She was funny. She was quick-witted. And when Luke McKay, you know, he was showing Alex Claremont his work, sort of taking samples from the side of these extremely hot springs, and then you can find a bunch of new living things there. Whether it's bacteria or archaea. That was his research. Well, he goes and meets with Rachel Smith, and she seems very nice and very funny and very affable. But then she says, we're going to this Keck telescope on Mauna Kea in Hawaii. And I think cross-disciplinary, there's a lot of respect and deference. But she did mention this, and she was one of the few to mention this. This telescope, I'm getting 2 nights here, or I'm getting a night here, and 365 nights a year, this telescope is fought over. And I had to write proposals and grants to get this one night, to do work this one night. And then once they had access to the telescope, you didn't see Rachel at all. It was Luke sort of narrating what Rachel was doing because Rachel was busy working. Now, I imagine cross-disciplinary, there's a mutual respect, but there is a competition for grant money and resources within a discipline. So I imagine there's a little bit of competition amongst scientists within a discipline that you wouldn't see if you have 2 scientists from completely different disciplines meeting each other, because they're not competitors. They're not competing for the same grant money. They're not competing for the same research dollars or facilities. So it's like, oh, I respect what you do. I know what you do, but we're not competitive. Do you see how that sort of makes this movie a little bit more brilliant? Because you just get to see the best side of the scientists. Now, if she had to spend the night with a competing astrophysicist who's looking over her shoulder or sort of leeching off some of her telescope time, she might have felt like that was invasive. But because Luke was in a completely different discipline, they were fast friends.
David, that's a very, very good point. When you began to propose a hypothesis and also arguments to support a hypothesis that you are bringing forward, and a colleague in the same field might have a little bit of alternative hypothesis that they feel is more important, then it is very, very easy to criticize research with people within your field. And they didn't have that. They didn't do that. In other words, you had people in different fields. If they were all the same field talking, then what'll happen is what not will happen, what could happen, what likely does happen is when they start talking about different hypotheses, they're going to start going back and forth. Yes, but, yes, but, yes, but, yes, but, and everyone's correct because they're analyzing their data, their approach, their logic, their scientific approach. And so it is a process, but there is no one way of doing things. And so, again, I never thought of that till you just brought it up. The beauty of this film is that they were not in the same discipline. They were in different disciplines, 1. And 2, they talked about their particular research that they were doing in that discipline. They were different physicists, but they were doing research in one area of physics, and someone else was not doing that. So there was no competition there.
Yes.
And it was more understanding what the different research was doing.
Yes. I think one of the scenes that I found endearing was Victoria Orphan. She met with Rachel Smith, and she was on the ship, and they were deep diving into the ocean to look at methane seeps. And there's this bacteria that lives in this wasteland, and the bacteria eats the methane and keeps it from getting into the water table, and keeps the methane from adding to the greenhouse gases in the atmosphere. And so it's like, so we need to study this bacteria because for thousands of years, millions of years, it's been preventing a climate catastrophe that would make life uninhabitable on Earth for humans. So we need to see how are they doing this, and maybe we could apply some of the lessons we learned from this bacteria in the real world. But also we need to understand what's going on there. With the methane seep is like a black box. So they were diving to the bottom of the ocean and taking samples and, analyzing the bacteria and the archaea that were in this methane seep. Well, she travels to Boulder, so shout out to Colorado, to meet with Jun Yi. And I always think of Colorado as the home of NOAA, the National Oceanic and Atmospheric Administration. But it's also home of the NIST, which is National Institutes of Standards and Technology. And that is, so shout out to Colorado, the timekeeper for the world is here in Colorado, just about 25 minutes north of my house. The timekeeper for the entire globe is in Boulder, Colorado, and Jun Yi builds atomic clocks. So to long-windedly get to the point of my story, she is a geobiologist from Caltech, and he had him and his team of, fellow PhDs and grad students explain how an atomic clock works. And so Victoria says, okay, so let me get this straight. You set this up, you do this, and you measure the change, and that's how you can tell the time. And they're like, yeah, that's exactly how. She was using more technical terms than that. But it's like, that's exactly how it works. Most people don't understand. We explain this to people, and it goes right over there. And she's like, yeah, I get the concept. It's like, so these scientists are capable of understanding each other on a fundamental level. But the fascinating thing was how they chose the order, too. Because she is taking samples, Victoria Orphan and her group that was doing a research on methane seeps, they were taking samples from the deep ocean trying to learn about a place. Jun Yi, he was one of the most confident scientists because they were trying to measure time. And the fascinating thing that they said was, we just keep getting better and better and better at it. So they're seeing successes. They're getting orders of magnitude more accurate at measuring time. So in his career, they're 1,000, 10,000, 100,000 times better at measuring time than they were when he started. And it's fascinating to see someone come from a discipline of, like, how do you measure time? And he builds atomic clocks, and the levels of instrumentation, the levels of being able to measure what's happening with these atoms, whether it's strontium or cesium, whatever. They use different atoms, and they use that to tell time, atomic clocks, and they've gotten more and more and more and more accurate. So he was one of the few scientists in the whole movie that had just consistently progressed his research, because his research was how accurately can you tell time. Now, a lot of these other people, they're trying to answer unanswerable questions, or questions where at the end of their lifetimes, their understanding will be a fraction, greater, not orders of magnitude greater.
Well, like Davide D'Angelo was talking about
dark matter.
Yeah, dark matter. They learn more and more about it, but it's like we still don't know.
Mm-hmm.
And so he said, "Oh, well, you don't know." He says, "No, that's not the point. Not the point that they know or don't know. The point is that we're learning about it." And Jun Yi was doing the same thing in Boulder with the timing. And he made a comment, which I think was brilliant. He said, no matter how good we get at measuring time, we will never end.
Mm-hmm.
It'll never stop, because time is something you can never, ever measure perfectly, because it keeps moving.
Mm-hmm.
And so that's when they started getting into philosophy of learning. And what are we learning? We're learning things that we don't know. How much do we don't know? Well, is it endless? Yeah, it is endless. No matter what you learn, there will always be something else to learn, and you'll never really get to the point where you know everything.
Yeah.
And Jun Yi illustrated that very, very well to me. Like, what is time? How do you measure time? And when you measure time, that was in the past. And how do you measure the future? How do you measure the present? It's something that always changes, and so you can never measure it.
Mm-hmm.
You can never measure it exactly. It's only approximate. And therein lies science.
Yes.
Is that you will never know anything perfectly. everything that we know as humans is an approximation.
Mm-hmm.
And the value we have is how close is that approximation to reality? And the closer it is to reality for our purposes, the more useful it is. And to me, that began coming out toward the end. Who was it? Was it Laurie
I believe.
Santos with cognitive psychologists began talking about the philosophy of learning and knowing,
Mm-hmm.
and it was very stimulating.
Yes,
Very.
I think they chose her at the end because she had some wrap it up type statements about why scientists do what they do. Sort of like it's like a mystery novel, and you do your work, and if you solve something, it's not the end of the book. It's like the cliffhanger at the end of the chapter, where like whatever you solve opens up new avenues of inquiry, and so you're constantly going down these rabbit holes as a scientist, and you realize there's more you don't know than what you do know. And I think that's sort of paraphrasing what she said at the end.
That's very close. Yeah, it's the same idea. Same idea. And really, the thing about science is that you'll never know, and it's a beautiful, wonderful field because no matter what you do, there's more to do.
Mm-hmm.
You'll never finish the building. You keep building and keep building and keep building, and I at the university I say the most important thing you can learn at a university is how to learn.
Yeah.
Because you should never ever stop learning and keep learning your whole life.
Now, I know we've given him a lot of airtime, but he's bolder. So, Junyi, what was fascinating to me, one thing that he said, and I think that all these scientists are capable of saying something that sort of blows your mind because they're doing work in such edge fields that it's like, wow, that's cool, was that time, we can measure it more accurately than we can measure anything. Length, mass, weight, volume, whatever. When you think of what you measure, he's like, we have the ability to measure all of those things, but the level of precision we have to measure time is way greater than our ability to measure anything else in this world. And yet at the same time, we don't really know what time is. And then, so they sent Junyi to Anil Seth in Sussex, England. And he's a neuroscientist, and his research is on the perception of time. So he would have Junyi watch videos and then estimate how long they were, based upon and then while he had like an MRI strapped to him or whatever, or CAT scan, something. It was 3D brain imaging. And so it's fascinating because the measurement of time is so much more precise than your ability to measure an individual's perception of time. So you go from one scientist that's doing something that's ultra precise to another scientist that's sort of like grasping in the dark to try to understand something that's very much imprecise. Like your and my perception of time is completely different. You know, how you experience a day, how you experience a year, and how long it seems to you is completely different than it'll be for me, completely different than it'll be for a 5-year-old child. And yet they're both studying time in vastly different ways. And I thought that was interesting how the movie chose to sort of have them meet up with each other.
Well, when he was done with the experiment, Anil asked Junyi, how do you think you did? He said, I think I did pretty good. And Anil Seth says, you didn't do very well at all. He thought he did well. Says, oh, I didn't? Says, no, you didn't. Because see, and said, oh, okay. And so again, perception is very different than knowledge. And so, and you're right. The perception of time and the measurement of time is very elusive. And it's fascinating. Again, beginning to learn two different perspectives of a simple thing that we all are in experience, and that is time. That's one thing that's common. Well, it's common. Who was it? Who was talking about relativity? Astrophysicist that says, yeah, well, time is. I can't remember who it was. Was it
Rachel or was it David? If it's a astro,
it might have been David, where relativity, if you raise it high or raise it low, your watch.
Oh, that was Junyi.
Oh, Junyi was saying that. That's right.
To Victoria outside on the campus of CU. That's my alma mater, by the way.
Yeah. And I don't teach in Boulder, I teach in Denver. But the point is, he was talking about how it changes time because of relativity. And I said, well, that's imperceptible, but theoretically, yes, but you're not going to be able to measure it. And so, but then right after that, he says, yeah, and if you get around any kind of heat or something, that's going to alter it. It. The point is that they're thinking about everything. They're taking the theory and trying to make some practical sense of it, and they're trying to connect the theory and thoughts with reality and what they're measuring. And it's a lifelong effort.
Are you wearing your watch right now?
No.
So we have this watch. I'll pull up a picture of it.
An F91W.
An F91W. It's the greatest watch ever made.
Shout out to the F91W.
The Casio F91W.
There it is.
It's about
not
a $10 watch.
Yeah, not a fancy one, just the one that does the job.
So I made this joke yesterday during the movie. He's like, yes, we're building the most accurate watches, accurate clocks in the world, the most accurate timekeeping devices that have ever been conceived by man. And then he shows her one of them, and it's like, yeah, it's probably off right now because the heat in the room is affecting it. And I'm like, yeah, it may be accurate, but you can't stand next to it. You can't move its level of elevation. It sounds to me like the F91W keeps better time than his fancy special clocks.
That's right. But they ask him, what accuracy? Like, what significant figures? 10 to the minus what? I think it was what he said, 10 to the minus 18th?
Mm-hmm.
18. 10 to the minus 18th, Well, in 5 years, it might be 10 to the minus 25th. Who knows?
And yeah, he's saying like very few fields can you actually improve your ability to measure by that much. And anyone that's measuring other things, the devices they have that take the measurements aren't as precise as the devices they have that take the measurements of time.
That's right.
And they're not progressing at the same level. So before we go, because I think we've covered this movie, I think it's great. I loved it. I will say one thing before we talk about Lori, because I want to end on Lori.
Yes.
She's the Yale cognitive psychologist doing research on an island of monkeys. But I do want to say, this is the first documentary I've seen since Cryptopia, Torsten Hoffman's Cryptopia. Ian Chaney's The Most Unknown is the first documentary I've seen that I really feel should be a Netflix series.
Good point. I agree with you, David. I agree.
If there was one thing about the movie that I have a gripe about, it's that what's the running time? Does it say? 1 hour, 32 minutes. It could have been 10 hours and 32 minutes.
It could have been.
And
yeah,
like Jennifer meeting David could have been an episode. David meeting Alex could have been an episode. Alex meeting Luke. And of course, it's funny to say, hey, Ian Chaney, I loved your movie. You should have done a movie that's 10 times as long. You should do 10 times as much work. It's easy for me to say that someone should. But I feel like if Netflix or Amazon Prime allowed him to do this as a show, it could be a fascinating show because you could maybe go a little bit more deep into the science, sort of have more revelations, and it sort of has this built-in globe-trotting component where, she's in the caves in Appalachia, and she goes to Italy, and then he goes to some other place in Europe, and then they go out to Nevada, and then they go to Hawaii, and then they go to the middle of the ocean, and then to Boulder, Colorado, and then Sussex, England, and then finally they end up on a monkey island just outside of Puerto Rico. And that's cool. And you could extend that for even longer, and you might learn even more about the science and sort of spend more time with these people. Easy for me to say, but, I wish it was 10 times as long. The hour and 30 minutes that we got was fantastic. I feel like it could be a TV show as well, though. And
well, David, there are programs out there, like travel programs. Today we're going to Budapest. Today we're going to Amsterdam. Today we're going to Rome. Okay. Well, you could do the same thing other than travel and looking at architecture and art do this type of model where say, oh, today we have a microbiologist looking at an astrophysicist, and they're going to be talking together. That's a 10, 15-minute episode. And there you go.
Yeah.
And that's really so fascinating. And you'd go to their lab and then go to the other lab, and one would talk to them, the other would talk to the other, and they would share notes and talk about what they're doing and discuss about, step back and just discuss about where they've been and where they're going and what their field is doing and how the fields care. And you can then go from a ecologist to a clinical biologist or a theoretical physicist to a mathematician. Actually, I didn't have any mathematicians in that. That was interesting.
No,
they didn't have statisticians either.
Yeah, but I think a mathematician is less science.
Yeah, but some of the mathematicians are like looking at different types of research of models within biology, mathematical models in biology, mathematical in Brownian motion, and mathematical models in physics, mathematical models in astrophysics. And
yes, I think that the thing is when you're inside of a cave, like Jennifer was, this guy was inside of a mountain to build his collider that was going to help him find dark matter. This guy had the Axel Claremans had the thing that you put on your head that allows you to move a robot arm just by Luke was by these hot springs. She was at this giant telescope on top of a volcano. These people were underneath the ocean. This guy could show and tell the world's Jun Yi could show and tell the world's most precise timekeeping devices. Neil Seth had his brain imaging experiments, and then Laurie had. So there was stuff to see. I think with a mathematician, it's like, oh, look at these complicated models I've built in my computer. That's less exciting than traveling places, I think, from a film perspective.
Yes, but I had a mathematical model that had first least squares. It didn't work. Nonlinear least squares. It began working. I pulled in geophysics. I pulled in statistics. I created an algorithm that could locate microearthquakes after a detonation. We went to the test site, and we actually saw a nuclear device, boom. And we saw the crater, and we saw the actual microearthquakes coming in real time. And that was exciting. It was classified at the time, but that was super, super exciting to see. Boom, 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 boom. And no one had seen that at that time. On after a detonation, this mathematical model was actually locating microearthquakes and how the stress with the medium, how it was releasing around the faults and the different layers in the bedrock, and how it increased, and then it decreased, and it was increasing around the faults, then it decreased. It was, of course, around the device. It also had microearthquakes at the surface around the device and the faults, but there was a blank in there, and you don't want those blanks to come together, and that's where you lose your containment, and the nuclear material will be released to the air, and you can actually. No one knew that. It was all seat of the pants up until that time, and that mathematical model actually demonstrated exactly how deep you had to go, and that space was how they're going to measure, and that was one of the research of a mathematical model.
Yeah.
Another mathematical model was on tsunami research, and we actually saw tsunami data. Anyway, I'm getting excited now.
I know.
Sorry.
I think there's a difference between, like, the mathematical model isn't what would excite people. The explosion would be what excites people from a film perspective.
Right. You're right. Yeah, talking about the model, yeah, but look, it would excite the scientist. I figured this out, and look, there it is. But you're right. But getting back to your premise, shout out. I think that this would be an excellent series. And how many people all over the world are learning and doing things. Yeah, a lot of this was empirical research to support theoretical hypotheses, but you could have different types of research also, all different kinds of research. And when you have something that's demonstrating what you're doing, it's fascinating. It's really interesting. I agree with you, David. this could be a series.
Yeah, and I mean, what I liked also about it is the subject sort of becomes the host. You know, you're seeing Jennifer do her science, and then she travels to try to learn from David. Jennifer sort of becomes the host. And then David travels to Axel. David sort of becomes the host. Axel travels
Yes.
to Luke. Luke sort of becomes the host. I liked that model, and I thought that worked very well.
I did too. It was good. Because what better host than someone who's a scientist and wants to learn it from another scientist?
Mm-hmm. And just so in closing, let's talk about Lori and
Yes.
the connection to the Channel 5 Q conference video.
Yeah, I mentioned that. Yeah.
So we watched a Channel 5 Q conference video, and at the end, Andrew Callahan goes and talks to the caterers. And so these QAnon people there sort of spouting all this conspiracy theory. And then the caterers, they're just a bunch of young kids that are just young and ornery. And they're saying stuff like, oh, your mama's got a big butt. And when we discussed the QAnon video about how we think Andrew Callahan included the caterers because they were just trying to get attention, just like these people on Facebook spouting conspiracy theories. So their level of discourse was exactly the same as the level of discourse of the people that attended the conference. You know, they may have seemed childish and it may have seemed like nonsense, but how was what the people attended the conference doing not nonsense? Well, I think you could take a similar look at Lori Santos's research on the macaque population of the island outside of Puerto Rico and say her desire to understand the behavior of macaques does
Monkeys.
teach. Yeah, macaque monkeys. You sort of see the way the monkeys behave, and there's some sort of reflection or echo of the way these brilliant scientists are behaving. So what will a monkey pay attention to? And they put a ball in this thing, and the person's looking at it, and they pull the ball out. And the monkey doesn't find that very interesting. But if they put a ball in this thing, and the person looks away, and the ball goes into a different, sort of like a 3-card Monte, different cup, and the human looks in the cup where it's not, they'll sort of be confused. The monkey will pay more attention to that. And on some level, looking into something and not being able to see it right away is what unites all of the research of the 9 scientists in the movie, and that's what inspires them to focus their attention and efforts on the pursuit of discovery. So the behavior of the scientists in the movie is not unlike the behavior of the monkeys on the island in Puerto Rico.
Then they had other experiments where they put the grape down and they turned their backs and they were going to go get it. But then if people were watching, then they wouldn't. And so what people were watching them do affected how they did it.
Mm-hmm.
Okay. And so sometimes they would, sometimes they wouldn't. But they didn't want to get in trouble, so they wouldn't say anything. But on the other hand, do humans care about getting in trouble? No, sometimes they'll say things just to get the attention.
Mm-hmm.
Okay, and in that case, the monkeys are probably more civilized than a lot of people. It was brilliant. It was brilliant. It was very clever.
I think that there's a through line in all 9 of these PhD researchers, all of their disciplines. There's a through line, and it's sort of the through line is being inquisitive, trying to seek knowledge, trying to find out truths that are heretofore unknown. And they're doing it with a diligence and, an attention to detail and a data-driven approach and using the scientific method. And they should all be applauded for their efforts. But like Lori says at the end, it's something that it's intoxicating to sort of pursue scientific discovery. And it's great to learn things. I mean, she doesn't exactly say this, I'm paraphrasing, but every time you learn something, there's a million new things to learn, and that's what is going to keep us going into the future.
And that's what makes us human. To be human, you have to keep learning, ask questions, and listen and learn. That's being that's being human.
So I'll play the outro music and just say, this has been our discussion of The Most Unknown, a film directed by Ian Chaney about scientists. And I would recommend it to anyone. I enjoyed it a lot. But this has been the Sons of Sequoia podcast, available wherever you get your podcasts. Starting next week, we will be switching from Monday, Wednesday, Friday to Tuesday, Thursday, Friday. So if you listen to this program on YouTube, be aware that our live broadcast will change days. So we're available on youtube.com and wherever you get your podcasts. And would you like to close out the show?
Yes, here at Sons of Sequoia, we feel that everyone should keep on talking, but listen more than you talk and try to understand what the other person is saying.